Welcome to Gaia Math Hub. Today, we are going to explore how big infinity really is. First, let's learn about a googolplex. A googolplex is 1 followed by zeros. Just imagine a 1 followed by a sequence of zeros stretching from Gaia to Dosso, or from Lagos to Ibadan. Even then, a googolplex is unimaginably huge. What if I told you that the universe cannot contain it? Yet infinity is still bigger than a googolplex. Let's look at this step by step. Million equals 1 followed by 6 zeros. Billion equals 1 followed by 9 zeros. Trillion equals 1 followed by 12 zeros. Googol equals 1 followed by 100 zeros. Googolplex equals 1 followed by a googol zeros. No matter how huge a number becomes, infinity is still bigger. Infinity is not a number, it is the idea of endlessness. Numbers continue endlessly, 1, 2, 3, 4, 5, 6, all the way to infinity. Has no end, but some infinities are actually bigger than others. You can count forever and still never reach that largest infinity. Take, for instance, the counting numbers, 1, 2, 3, 4, and so on. This is an infinite set. Now look at the numbers between 0 and 1. Within this interval, there are infinite decimals, 0.5, 0.65, 0.725, 0.00245, and so on. Infinite rational numbers, like 2 over 5, 7 over 11, and so on. Infinite irrational numbers like pi over 10, square root 2 over 5, and so on. Endless non-repeating patterns, 0.1234, 0.43901, etc. So, there are more numbers between 0 and 1 than there are counting numbers altogether. Now, let's examine another scenario. A hotel has infinitely many rooms, and every room is already occupied. A new guest arrives. Normally, that should be impossible, right? But the manager says, move every guest from room N to room N plus 1. Now room 1 becomes empty, and the new guest can enter. In fact, the hotel can still accommodate infinitely many more guests. The lesson here is that infinity can grow without becoming bigger. Another interesting idea we will examine is called Zeno's paradox. Imagine you want to walk to a wall, W. First, you walk halfway, W2, to the wall. Next, you walk half of the remaining distance, W4. Then, you again walk half of what is left. You continue doing this forever. Since there is always another half distance left to travel, the paradox asks, can you ever truly reach the wall? Mathematically, there are infinitely many steps. Yet you still reach the wall. In formula form, W2 plus W4 plus W8 plus W16 plus equals W. Finally, infinity can fit inside finite time. In other words, infinite processes can still produce finite results.